So I'm going to go over solving inequalities on this video. Please ignore this on the right. If you could see these, this is my drive. Solving inequalities. We've been solving equations, and now we are going to be solving inequalities. So let me get my pen ready. Remember inequalities. So remember, if we have this or this less than, greater than, we have or not equal to, this is an open circle. If we have less than or equal to, greater than or equal to, or just equal to a specific number, then we have a closed circle. Okay? And remember, going left is less on the number line, going right is more. All right. So far we've just been graphing one variable inequalities, not solving anything, just graphing them with open or closed dots. And so now we're going to solve some. So what's the solution set to this? So this is a two-step inequality, and you follow the same steps as if it was an equation, but there's just a little trick. And I will show it to you after this, because right here we're going to focus on the variable and the coefficient is 5, which is positive. So there's no real changes as if it was an equation. So our first step, this is a two-step, is to minus 10. And we get 5q greater than 10, 20 minus 10. And then our last second step, it's a two-stepper, is to divide by 5. And so q is greater than 2. When you're doing your assignment, if you don't have a printed copy and have a number line, I want the center number to be the focus, the answer, and then go up to and go down to. And then I could change my pen to a different color. At 2, it's going to be an open dot because it's not equal to, it's just greater than, and greater than goes this way. Okay, you need to be able to recognize it if it looked like this or if it looked like 2 less than q. Okay, that is saying q is bigger than 2, so you go to the right. Okay, so now we're going to do several of them. All of these looks like the variable is positive, so I don't have to show you the little trick yet. But when the coefficient to the variable is negative, then our final step, then we have to do reverse the symbol. And I will tell you why on the next slide. Okay, so here's 5 examples. This is a one step, so you just subtract 4. Again, I'm going to focus on 3, 4, 5, and 3, 2, 1. I'm going to solve them all, and then I'll go back and graph them all because my pen color. So this is m divided by 3 is not equal to 1 because I subtract the 8. And then this is division, so you have to multiply. So 3 times 1 is 3. Again, I will focus on 3, 4, 5, and go down to 1. This one is variables on both sides. If I subtract the 7y, I get y plus 4 less than negative 2. Now if I add the 4, subtract 4, those cancel. I get y less than negative 6. My focus is going to be negative 6. I'm going to go up, so negative 5, negative 4. I'm going to go down, negative 7, negative 8. This one I have to distribute, so I get 6x minus 30 greater than or equal to 30. So remember, distribute to both. Now I'm going to add 30. Sometimes when this is a negative and the number cancels, you get 0. And sometimes people get confused, but 0 is still on the number line and it's still a number. But this case, we don't get 0, we get 60. 6 times 10 is 60. So my focus is going to be 10, 11, 12, 9, 8. This one you have to distribute for both sides. Now I'm going to have to move the x. You can move the 4x the other way. Oh, if you move the 4x the other way, we're going to be dividing by a negative. Try to keep your x, your variables, positive when you're doing this. So since 4 is bigger than 2, I'm going to move it to the left. If I were to move the 4, I'd be a negative number here because 2 minus 4 would be a negative 2. Try to keep your variables positive when we're doing the inequalities. So I get 2x minus 12 greater than negative 4. Add 12. 2x greater than 8. X greater than 4. And I'm going to have to draw my number line here because I ran out of room on my underneath it. So 4, 5, 6, 4, 3, 2. They're not evenly spaced. Okay, so let's go back and do the graphs now for these, and I will use black. So let me get a little fatter marker. So at 3, this is a closed dot because it has the equal underneath it, and it reads x is less than 3. If you are confused, what helps me is to read it out loud. People recognize the inequality out loud. So x less than 3. So there's that one. This one is only one thing. X is not equal to 3. Or m, sorry. So this is an open dot, but it could be any other number on the number line. So you have to go both directions. Open dot at 3, every other number. 3.05, that is okay. 3 even, not okay. This one at negative 6, I have an open dot. Y is less than negative 6, so it goes left, less than. This one at 10, I have a closed dot because it has the equal sign underneath. X is greater than 10. And the last one at 4, I have an open dot, and X is greater than 4. Okay, so let's go back to my pen and go to the next page. So those are the graphs. All our variables were positive. So now what happens when a variable is negative? Because since we have to a negative times a negative is a positive, we think of that of changing the sign. Whenever we multiply or divide by a negative, it changes this negative to a positive, changes the answer to a positive. If we multiply a negative times, I'll do a star this time, a positive, then the answer is negative. And what that does on a number line is reverse directions. So your answers are reversed whenever you multiply or divide. This is same with division. So if whenever you multiply or divide by a negative, you have to reverse your symbol. And you could always check your answers. So like if we go back to the previous page, okay, so this is saying 1 will work. 1 plus 4 less than 7? Yes. This is also saying 5 will not work. You could always check your answer. So 5 plus 4, that's 9. 9 is not less than 7. So when you are adding, multiplying or dividing by a negative, you could always check your answer. So this one, we don't, sometimes you end up with something like this, a negative x or a negative q. We don't want to know what negative q is. We want to know what positive q is. So all you do for these, reverse both signs. So I'm going to multiply by a negative 1 on this side and multiply by a negative 1 on this side. I'm sorry, I'm using the text and you're going to have to write it. But this becomes a positive q. And then since I multiplied by a negative, I reverse that symbol to, instead of greater than, it becomes less than. And let me show you on the number line. So when you're checking it on the number line, you have to check it to your original problem, not to your changes. So on the number line, I'm going to have a closed dot either way because it includes 7 because it's equal to. Now our final answer is this way, less than. So let's check it. A -5 is greater than -7. Yes, that is true. If I hadn't flipped the symbol, I would go this way, and it would be 9. -9 is greater than -7. That is not true because remember on the number line, I have -9, -8, -7, -6. -9 is not greater than. When we're going to the left, it's less than. Okay, so let's practice changing that symbol. Another thing you could do is add it and move it to the other side and move this 16 to the other side, and then you don't have to switch the signs. But it's only your last final, your one step that you are reversing the symbols. Okay, so this one I'm going to divide, oops, I like green. This one I'm going to divide by a -2, divide by -2. So I get F. Now since I divided by a -2, I'm going to reverse that. So I'm going to write my number line, 8, 9, 10, 7, 6, and I'll graph it next, and then we'll check them when we graph them. This is division by a -12. Sometimes they put the negative right in the middle. Sometimes they put it by the 12. It could even be with the X. But it is one negative, so I'm going to multiply by -12. Multiply this by -12. Since I'm multiplying by a negative, those cancel. I need to reverse my symbol. 1/4 of -12 is -3, because 12 divided by 4 is a -3. This is a long number line, but there's -3, -2, -1, -4, -5. You could write more numbers if you want, but I just want to have at least 5 tick marks, 3 numbers. Okay, this one, if I subtract the 6, I could show you on this one how to make the variable positive. I'll do that. So if you do it the 2 steps, it would be a -a greater than 9. But if we want to make, we want the variable to be positive, then we don't have to worry about flipping symbols. I say flipping, but it's reversing the symbol. So I could add a, but it's more steps. So I get 6 greater than or equal to 15 plus a. Now I subtract 15. So I get -9 greater than or equal to a. And this is an a. Okay, so my focus is -9, -8, -7, -10, -11. And then this one you have to distribute. I don't know, I was going to say distribute the -3, and then I thought it's 6, and I wrote 36. Okay, -6x minus 12 greater than 0. So just because 0 is on this side, it's still a valuable inequality. You don't not write the 0. You always write the 0 and treat it like a number. So I'm going to add 12, -6x greater than 12. So I divide by -6, and I get x, flip, reverse my symbol. -6 is a -2. I don't know what happens when it's off the white area. Well, I do know what happens. If I try to make a PDF, it won't do it, that part. Okay, so -1, 0, -3, -4. Okay, let's do the inequality and check it when we do it. That's a good habit. So at 8, I'm going to have an open dot, and I'm saying greater than. So easy numbers to check. Right here, an easy number to check would be 10. The ultimate easy number would be 0. Does 0 work? It shouldn't, but 2 times 0 less than negative 16? No, because 0 is like over here, negative 16 is over here. This one at negative 3, I have a solid dot, and I'm going greater than. Now 0 will work. So 0 divided by 12 is 0. 0 is less than 1/4. Yes, it works. You could also try 10 here, and 10 should work. Okay. Here, a closed dot at negative 9, greater than. This one I did not reverse the symbol, so let's try. 0 should work. It's over here. 6 minus 0, greater than 15. I made an error. Where did I make that error? Oh, I made the error drawing my arrow. So my arrow is not saying A is greater. My arrow is saying A is less than. So A is less than. I still have a closed dot, but see, negative 9 is greater, so I have to go this way. Okay, so 0, 6 minus 0 should not work. Greater than 15, and it does not. Can you see the gears in my brain working when I pause? Okay, so the other thing, you could rewrite it this way. Just make sure when you rewrite it this way, your symbol, this is saying A is less than negative 9. Okay, your symbol works. These two are the same thing, even though they're different symbols. And the last one, an open dot, X is less, so 0 should not work. Extend those lines. Okay, 0 should not work. 0 plus 4 is 4. 4 times negative 3 is greater than 0. 0 does not work, so that one's okay. All right, so you got to remember to either reverse, flip your symbol, or move your variable to be positive. It's been easier for people to reverse the symbol. So your assignment this week, worksheet with 20 inequalities. If you don't, it's the one I'm passing out with the packet. If you don't have a printed copy, at least 5 tick marks, 3 numbers, okay? 3 numbers, 5 ticks. And make the center the focus of your answer. Let me know if you have any questions, and I will post this on YouTube. Thank you. Let me see if I can stop it.